Hello everybody, and welcome to today's webinar entitled Do Data Science Faster with IBM's Integrated Analytics Systems, the Next Generation Data Appliance. My name is Steve Leet. I'm the Practice Director from LPA, and presenting with me today is Steve Tesler from IBM. So just a quick background on LPA. We were founded back in 2001. We are headquartered in Rochester, New York. We are an IBM Platinum Partner, and we have approximately 40 consultants across the U.S. LPA's offerings span the entire business analytics spectrum. If you're new to analytics and just getting started, LPA can help you with offerings such as the BI strategy and roadmap, readiness assessments, and business case developments, creating ROIs for your required investments in analytics. Today we're going to be focusing in on the next generation data appliance, the IBM Integrated Analytics System, or IIAS. As I mentioned earlier, helping me today is Steve Tesler from IBM, who will be providing a high-level overview of IIAS to you. So with that, Steve, over to you.
Thank you, Steve. So if we think about high level for a minute, an ideal analytics solution, and more particularly the underlying data that supports that analytics solution. Strategy, the preference, the desire here would be, in an ideal world, not to be limited where you as a customer delivery for these solutions, not be limited where you put that data. You want to maximize options based on requirements. Requirements can change over time, and you want the flexibility to change as those requirements change. Options could be on-prem, in the cloud, structured data, unstructured data with platforms like Hadoop. But again, as the environments change, requirements change, technology changes, you'd also ideally like the ability to be flexible, to change with those changes, support new workloads, new technologies like machine learning, and be able to scale to meet future workload. And then, of course, do all this with an extremely high degree of performance to meet the needs of the business and help ensure SLAs are met or exceeded, for that matter. Okay. So IBM, what we bring to the table, IBM and our vision, if you look at start at the top right of this chart, is initially what I just described. Deploy your data where you need it, when you need it, with options for flexibility, including on-prem or in the cloud or both. And continuing clockwise, bottom right, also the ability to write once, build your solution once, but if the need to move the data or expand the data from one deployment option to another, potentially on-prem to start and then move it to the cloud, or vice versa, be able to write it once and then access the data on any platform without having to rewrite or migrate. Continuing clockwise. Of course, do all this at lightning speed to meet the needs of the business and using latest technology, including HTAP and Blue acceleration that Steve will discuss in a few minutes. And then the top left, do all this, again, with more intelligent analytics, embedded machine learning, and HTAP. And again, we'll talk about that a little bit more in this session as well. So again, the IBM perspective, continuing to redefine analytics. We're deploying environments data scientist friendly, built-in data science experience in our technology, leveraging Apache Spark and others, machine learning ready, scalable model training, deployment, etc., all with near real-time and high concurrency workloads. And just to boast a little bit, but as a reminder, IBM was first with machine learning and an integrated platform, first with no-cost encryption, first for an analytics data warehouse appliance, first with a petabyte data warehouse, first with a 100 terabyte warehouse appliance, and first with a data warehouse appliance. So continuing to innovate and meet the growing and changing needs of this dynamic industry. So the underlying IBM strategy is about hybrid, and hybrid in many forms and factors. So we're not just advocating data warehouses and database in the cloud only or on-prem only. It's about deployments in the cloud and on-prem. It's not just about traditional relational or open source. It's hybrid. It's about relational and open source. It's not just about the SQL syntax or no SQL. It's about both SQL and no SQL. And it's not just about structured or unstructured. It's about both. So when we talk about a hybrid data management platform options for data warehousing, it's all the above. And again, performance is of vital importance. Performance increases on existing workloads is what we're delivering. Deliver existing analytics faster, but optimizing for the future workloads. And again, we'll get more specific in the technology, but looking not just to do what we've been doing, but faster, but also handling the new requirements, leveraging new technologies and cloud-ready types of deployments as well. So I talked earlier about the various deployment options, and let me get a little more specific, all underlined with our write once, deploy anywhere with a common SQL engine that says, so as you build a solution that uses SQL to access data and you move the data, that same SQL can still access the data wherever it resides. And so our deployment options that IBM offers in this portfolio, left to right, starting with a managed public cloud environment. We have DB2 on the cloud for transactional workloads and DB2 Warehouse on the cloud for analytic workloads. Again, fully managed in the cloud. No need to worry about backups and data management, index creation, etc., all handled in the cloud. Continuing to the right, a software-defined environment, on-prem, Docker container technology, or private cloud. DB2 Warehouse is the name of the product. Again, it's the same software as DB2 Warehouse on the cloud, but it could be run on-prem or in a private cloud. Continuing to the right, a dedicated analytics system in an appliance form factor is the new Integrated Analytics System that Steve will be talking about in much more detail. But again, the same software across all these environments. And then our custom deployable database, DB2, which is the latest and greatest enhancements to our legacy relational database technology, run on-prem, deployment option, but again, it also runs in the cloud. And finally, Hadoop, best served for unstructured data, yet at the same time typically requires a good deal of skill and elbow grease in order to develop applications on Hadoop. A lot of proprietary technologies, or I'm sorry, not proprietary, but a lot of technologies that are not abundantly available in most enterprises. Yet with IBM's big SQL technology, we take the same SQL that supports all these other database deployments that I've been describing, DB2, the Integrated Analytics System, etc., and extend that to Hadoop. So if you've got people skills developing SQL-based applications, or if you've got tools that generate SQL to access data, that same SQL can be used to access Hadoop data. So there's deployment choices and flexibility in the hybrid environment. And as I alluded to earlier, you may start with one deployment, the needs change, and you may switch to another or augment to run in multiple platforms and environments. But with this common SQL engine, you won't need to rewrite or move the applications. They will continue to access data wherever platform deployment options are selected. So now let's go a little bit further into the Integrated Analytics System, the appliance form factor. And with that, let me turn it back over to Steve.
Great. Thanks, Steve. So what we're looking at here is the convergence of offerings into the single common SQL database engine offered by that IBM has today. For existing clients, you'll know that PDA, or Pure Data Systems for Analytics, was built on the Netezza technology. And the IBM Integrated Analytics System is built on the DB2 warehouse software as the basis for the data warehouse. For you, what this means is it puts all of your hybrid data management infrastructure into the same tools that you're sharing and the same set of skills. So no longer do you have to worry about having a set of DB2 skills and a set of Netezza skills. Now everything is all the same, giving you great advantages and savings. The Integrated Analytics System is a unified data science platform. Everything you need to do to connect your data scientists with the data and to provide them with the right set of tools is in this solution. And we'll talk a little bit about that. So let's start with the common SQL engine. This is about workload portability and skill sharing across public and private cloud. Data science tooling is built in. IBM Data Science Experience is included, which allows data scientists to collaboratively analyze the data, or they can use their own tools like Jupyter Notebooks. Ease of use. Some of the core elements of the solution, such as reliability, elasticity, and flexibility, are standard, and it simplifies your management of resources. Hybrid data management, as Steve was saying earlier, supports the broadest array of data types and workload deployment options so that data scientists are not limited to what data is available to them. In-place analytics runs analytics where the data resides, reducing the processes and increases performance. And this is done using the Apache Spark processing engine. Machine learning, new types of workloads that your data scientists need to accelerate decision making, bringing new opportunities to the business. And performance. As an optimized single solution, it is easy to deploy and manage while still providing the highest levels of performance that you'll need. What we're looking at here is really, this kind of expands on the ease of use and the way that the integrated analytics system simplifies management and maintenance. Let's talk about some of the things that you're not going to have to do anymore with the integrated analytics system. You don't have large groups of administrators to manage it anymore. Everything is a unified system. We've spoken a bit about the common SQL engine and data virtualization. Here your data is no longer trapped on the system. Tuning and configuration is done by IBM before the system even arrives, and you don't have to worry about any indexing. Let's look at some of the positives. You can load data and start querying it within hours and not days. There's a number of migration tools that will help you to move the data and share workloads are shared across the different platforms with a common SQL engine. There's one management console is used to manage the entirety of the hardware and the software. Performance is optimized, and we'll get a little bit more into this in the presentation a little bit later. We'll talk about in-place expansion, which extends far beyond what you might have seen in previous or competitive offerings. And of course, since this is an integrated system, it's supported through a single serial number. Where the IBM Integrated Analytics System really excels is that it brings together your data scientists with the data in an offering that is easy to manage, high-performing, and always available. IBM has taken the data science experience and they've built it into the solution so that your data scientists have the tools that they need to start working on their analytic models. They can also use the Jupyter Notebooks if that's what they really want to use. The embedded Apache Spark processing gives you a number of improvements. Without having to move your data and having the analytics run right in place, not only does it reduce the workload for you and your data scientists in the model building process, but it also increases performance. Next, there's machine learning that your data scientists can take advantage of. Again, it's about connecting them with the right data and then giving them the tools to deliver the game changes to the organization. Having machine learning is a competitive differentiator for you. The system itself can work with data across all types and platforms and locations, and the expansion for scalability as well as being cloud ready to move workloads to the cloud if that is what the requirement is. It's all about offering you the flexibility and the options to meet your business requirements, as well as having the reliability and disaster recovery options to ensure that your system is always up to meet your service level agreements. For those of you in IT, analytics are the foundation of the business user's ability to do their jobs. Marketing, sales, operations, more and more groups are asking for analytics or they're becoming critical to their success. And not providing this functionality is not an option. So how do you propose to address this mountain of incoming requests? Do your business professionals see you as the bottleneck to the success or as a partner? How do you plan to support them when they start to explore more cutting-edge use cases like machine learning? Is your IT department undergoing cloud transformations, and does it match the data policies for the different use cases that are being presented? What type of solution is going to get you the performance that you need to deliver on these use cases? You need to be the driver to a more competitive position of your company. And if you have the right solution to address these issues, you can become that driver, the driving force. For the business users and data scientists on today's call, the analytics you get from IT are critical to your success because the insights coming out of these analytics are making you sharper at doing your job. They're driving your competitiveness. So how is IT helping you with your requests? Do you see IT as your partner, or are they the bottleneck to your success? Are there advanced analytics that you want to use to help transform your organization? Things like machine learning. Analytics that perhaps require higher levels of performance that you can currently get. What amount of analytics do you need to fully support your department? And if you're a data scientist, your business professionals. Much of the work needed to address your business professionals and data scientists is going to happen on an analytics platform or a data warehouse that you will be managing. The challenges with managing these systems are, with a system like this, can be significant. There is an explosion of not just data volume, but it's coming in across various different data types and across multiple locations and platforms. You need to be able to address some of the new analytic workloads that you're being asked to run. And this can either be performance-heavy workloads like real-time monitoring, or newer workloads that are specific to machine learning models. And finally, there's also the overall performance and management of the system. You need something that is easy to manage and deploy, and that's going to free up your staff to driving innovation and not get bogged down with the day-to-day maintenance, and not to drive up your budget with people resources that are not helping innovate on the business. And then there's the cloud. The cloud is most likely a big part of your strategy, or will be soon, and is something that you're being asked to address. You know that you probably need a hybrid environment, and picking the right location giving you the ability to pick the right location for the right workload. You need to make sure that you have interoperability, and you want to make sure that the systems are all going to work together. There are some workloads that will simply never move off of your data center, and those need to work well with the ones that you do move off to the cloud. More importantly, you want flexibility so that what might be a right fit today can be changed tomorrow should your requirements change, and not have to worry about rewriting all of that code. So let's talk a little bit about the optimized hardware. As we mentioned earlier, the most reliable and highest performing server and storage components were selected for the system. The IBM Power System architecture has a reputation of high performance and high reliability in the market. IBM also gets performance enhancements through the use of the Power architecture with things like the single instruction multiple data, or SIMD technology. SIMD allows for the same instruction to be applied to multiple pieces of data in parallel at the hardware level. Additionally, these algorithms are designed to scale with the number of cores available in the system. Flash storage is standard. Flash is going to provide near real-time latency for higher data transfer speeds. And later in the presentation, when we talk about expansion, you'll see that on the storage side. But the server and hardware combined have to be a balanced pair. And IBM adds server and hardware in balanced pairings to ensure to match performance and maintain the highest levels of efficiency in the system. As you can see here, the power systems were chosen because of the high performance of the architecture. IBM Power 8 is the first microprocessor designed for big data and analytics, and offers a number of advantages. When systems are designed for big data, there are a few key attributes that are important to create a balanced system design. First, having the processing or computing capability. Second, having memory capacity and bandwidth. Third, it's cache capacity and latency. And finally, I/O bandwidth, i.e. the ability to move information in and out of the system at rapid speeds. At the software layer, technologies such as Blue Acceleration are bringing unprecedented storage savings and performance acceleration for analytic workloads. Column organized tables store each column on a separate set of pages on disk. Organizing the data by column on disk reduces the amount of I/O needed for processing queries, because only the columns that are referenced in the query need to be accessed. With data skipping, DB2 skips reading ranges of column values that are not needed to satisfy a query, and doesn't require any configuration or maintenance to use. With actionable compression, column organized tables are automatically compressed using an efficient compression algorithm. This industry-leading compression results in significant storage savings over the traditional database compression technologies, and better query performance, and allows for efficient use of memory because more compressed data can be stored in memory. We've spoken about the Common SQL engine and how that opens up the levels of flexibility you have with the types of data you can connect with your data scientists, regardless of where it lies. With the IBM Integrated Analytics System, it's all about being part of your hybrid data management strategy and fitting in with things like the IBM Data Server Manager. This not only manages the system, but can also be used for DB2. Having access to data regardless of where it resides, or whatever data type it might be. And again, if you need to move data to the cloud, you can do that seamlessly, without rewrites. And of course, the support for semi-structured and unstructured data, like Hadoop. This is great for ensuring that regardless of technology or type, that the data is available to your data scientists to use. You might have seen this functionality described as IBM Fluid Query in the past, but this is built in as part of the Common SQL engine and its data virtualization. The way this works is that you write your application to pull data from the IBM Hybrid Data Management Common SQL engine. The access is then transparent to your application with regard to where it resides, and this includes non-IBM databases. When you think about expansion on the IBM Integrated Analytics System, it's important to think about it in two ways. First is the actual hardware. The IBM Integrated Analytics System offers in-place expansion that is non-disruptive. So when you order your system, if you need to add more compute or storage, it's done without disruption to your system as you scale out. The other aspect of expansion is cloud readiness of the Common SQL engine. Workloads that you have on one system can seamlessly be moved to the cloud based on your requirements. You have the option to put workloads where you need them for a greater level of flexibility on how you want to run your infrastructure. For storage, there are two key aspects to expansion. The first is that the IBM Integrated Analytics System is, as I mentioned, is non-disruptive. Here you can independently scale the storage for more cost-effective capacity and growth. The other is the multi-temperature storage. As you know, flash storage is standard on the IBM integrated system. This, however, allows you to keep the most frequently used data, or hot data, on the flash systems. You can then place the less frequently accessed data on colder enterprise storage systems. When thinking and planning on how you would use the integrated analytics system, consider some of the following usage characteristics for how you'd place this type of solution in your organization. Connecting to your hybrid infrastructure, where you have a common SQL engine that is simplifying the movement of data to the right platforms and locations where data needs to reside, but not restricting that access to your data scientists who need to connect to it. Where performance is critical to the workload, this could be operational or mixed workloads, or just where time to insight is needed and current systems do not have the speed to deliver. Where data volume is a big part of workload, imagine a retailer who has thousands of SKUs that all need to be loaded into the data store. When in-place analytics are needed for speed and simplification of processing. When new types of machine learning analytics are required by the business to stay competitive. Or how about rapid deployment, when you need to load data and start querying in hours, where you want to ensure IT is not going to be seen as a bottleneck as you're taking on new requests for analytics. Or how about where Hadoop is part of your data that you need to connect your data scientists to for their analytics models, and you don't want to have to worry about the data types or platforms or locations, but rather you just want to connect the data with your data scientists. From an architecture point of view, or from a configuration point of view, I should say, IIAS starts with filling 1/3 of a rack, then expands to 2/3 or up to a full rack. Multiple racks can be configured to be a system as well. As I've already mentioned, these systems are all part of a single part number, one serial number. So any issues, it's one call to IBM support with one part. This is a high-level overview of the actual hardware configuration in each rack, and I'm not really going to go into any details. I'm sure you can read that as fast as I can talk it. But one important thing is to note is that it's Not just that these are all put into the rack at your convenience, compared to having to build it all yourself. It's also about the configuration and optimization that IBM does to make sure that the settings and the configuration of the machine is created for the purpose of running your analytics faster. So with that, I'd like to say thank you for your time today. We do have a couple of things coming up for the data scientists. We have a couple of webinars that are coming up around the data science experience that I'm sure you'll find very informative. In the near future, we will be having another webinar focused on, this time on the move from Netezza to the next generation appliance, the IBM Integrated Analytics System. And finally, if you are interested in kicking the tires and you would like a POC, please reach out to me directly. That's steve.leet@lpa.com or sales@lpa.com, and I'll be happy to discuss those details with you. All right, so we're right at the end of the scheduled presentation, but I will try and answer a couple of questions that have come in. Please feel free to continue to submit your questions via the chat window or email them to me directly, and I will send out a follow-up email over the next couple of days with answers to all of the questions that we receive. Okay, let's take a look here. There have been a number of similar questions along this thread. The question is, can I add additional disk as needed, and is there a limit? So this is a great question. The simple answer is yes. Unlike prior appliances, which had a fixed capacity, you can add additional disk space at any time. In fact, without interrupting your current production. However, it's not unlimited. The amount of additional disk space you can add is dependent on the size and configuration of your appliance. Okay, next question. Let's see, we are in the process of building a POC using -db. Can I truly pick up the code that has been developed and transfer it to the appliance with no rewrite required? So yeah, so this is a great question, and in fact with a very simple answer. And I'm going to go back to a previous slide to answer this question. Let's see, where is it? Here we go. So the simple answer is yes. The Common SQL engine that Steve Tesler from IBM was talking about during his presentation, it really means that regardless of where or how you're storing your data, it all uses the same DB2 code base. And that, coupled with data virtualization, you have a true hybrid environment that allows you to move from ground to cloud, or vice versa for that matter, with no downtime, no rewriting of stored procedures or ETL or reports or anything like that. So really, if you take a look at this slide here, you can start anywhere, move up, move down, move left or right, and it's all based on that same Common SQL engine. So you have no issues with that. All right, so that really we ran out of time. We actually ran a little bit over. So I do want to thank you for your time today. If you do have any more questions that I didn't get a chance to answer, please shoot me an email, or if you'd like to follow up conversation again, you have my email. Excuse me. You have my email address, so please shoot me an email, and I'll be happy to respond. All right. Well, thanks very much, and enjoy the rest of your day.